I have 6 p.m. Thank you all for coming tonight to Our American Roots. I hope you are going to learn some things tonight. I hope you're going to enjoy the program that we have. And I want to start off with something that is necessary, okay? And I'm going to read it. In the unlikely event of an emergency requiring to evacuate this facility, those of you sitting in the front of the auditorium should exit immediately via the doors on the left and the right sides of the stage. And it says I'm supposed to point to them. Okay? Those of you in the back should evacuate via the doors to the left and the right of the rear of the auditorium. Once in the lobby, exit the building through the doors to the right. Should one or more of these exits be blocked by smoke or fire, please leave via the nearest alternate exit. Get out of the building any way you can. It's not in the script, I agree. Megan Millwood, the president and CEO of ORAU, is going to welcome you to the Pollard Center. And then Alan Lowe, who's the executive director of the American Museum of Science and Energy, the K-25 Atomic History Center, the Wilcox K-25 Interpretive Center, and soon to be Portal 4, will introduce the panel and the program. Megan?
Thank you. All right, good evening, everyone. What a great crowd. Welcome to this exciting event. I'm looking at this esteemed panel. I know this is the first of 4 programs, but I don't know how you're going to top this with the rest of the programs. I'm looking forward to seeing what they are. But we are honored, as Ray said, I'm the president and CEO of ORAU, and we are honored to welcome you all to this Our American Roots and Exploration of Cultures program. We're honored that this first program is being held in our recently renovated Pollard Center here at ORU. Hopefully you got to enjoy milling around and eating some of the good food that was provided this evening. And also want to extend a special welcome to each of our esteemed panelists. Again, appreciate all your time for being here this evening. And we're very proud to be one of the sponsors of this event. And I'm personally excited to hear from the panelists about what lessons we can learn about our future for artificial intelligence, and any lessons we can learn from the past should benefit all of us. So I will take another moment. I won't hold us up too long, but just take a quick moment to give a shameless plug for our Museum of Radiation and Radioactivity. Hopefully you got a chance to look at it, but if you didn't, take a look before you leave. It's just in the hallways and out in the lobby. You're going to see a lot of very interesting things about nuclear history, such as an image of a control panel button from the Chernobyl disaster that we have in our vault, and to nuclear medical advancements made right here in Oak Ridge. So if you didn't get a chance, take a minute after the event this evening and look in our museum. And again, welcome to this fantastic evening. I hope you find it interesting and educational. So I'm going to turn it over to Alan. And Dr. Streifer, I'm going to allow you to put this back in your...
I thought you found a way to keep me quiet. It was great.
We don't want that, Stephen. Good evening, everyone. Welcome. Thank you so much for being here. We're very excited about tonight's program. As Megan said, I'm Alan Lowe. I'm the Executive Director and CEO of the American Museum of Science and Energy. We've now called all the buildings at K-25 the Atomic History Campus at K-25. Not quite the mouthful now, because we're really growing with all of our facilities out there. I'm really pleased to be part of the Our American Roots programming. It's an amazing resource for this community. The topics, the speakers they have, really terrific. I applaud the organizers. I should note, shamelessly, that I'm moderating another one of these on March 3rd, this time at AMSI, all about the First Ladies and their societal impacts. Those of you who know me know that for many years I worked for Presidential Library, so I'm going back to my old life there, and going to be a fun night there at AMSI on March 3rd. Again, before we get started, I want to thank Megan, everyone at ORAU for the use of this beautiful Pollard Center, and AMSI Foundation, I must say, is very excited about our partnership with ORAU. And finally, the last part of our program tonight will provide some time for the panel to answer your questions. but it's important that you submit those questions in writing beforehand. So you received, when you checked in with the program, I do believe, a comment card. When you have a comment, go ahead and raise your hand during the program, and we have folks who are going to come up to the ends of the aisle. So on either far end, you can pass them down after you raise your hand. They'll come by and pick those up. We'll stop taking those questions about 6:45, and then we'll start answering your questions around 7:10 or so. So when you have that question written down, at any time, raise your hand, and they'll come grab that from you. All right. I think I've done my duty in that now. So again, thank you for being here. It's my honor now to introduce this panel. First, to my far left, we have Dr. Stephen Streifer, who since 2023 has served as director of the nation's preeminent multidisciplinary lab, Oak Ridge National Lab. Prior to coming to Oak Ridge, he served as interim director of the SLAC National Accelerator Laboratory at Stanford, and before that in leadership positions at Argonne National Lab. In Oak Ridge, Stephen has been truly tremendous. He's not only continued but expanded Oak Ridge National Lab's excellence, including in AI, and he's shown a great ability to connect with this community and to communicate with all of us. So, Stephen, thank you for being here.
Pleasure to be here. Thank you.
We have Dr. Lynn Parker next to me on my left, who led national AI policy for 4 years at the White House as Deputy Chief Technology Officer of the United States and founder of the National AI Initiative Office. Since then, she founded the AI Tennessee Initiative at UT, where she's now a professor emerita and a continued influential voice here and across the nation on all things artificial intelligence. Next to me on my right is Dr. Ashley Stowe, the Chief Research and University Partnerships Officer here at ORAU. Prior to that, Ashley served at Y-12, including service as the director of Y-12's Oak Ridge Enhanced Technology and Training Center, or ORTIC. In both roles, Ashley brought to the table an understanding of how technology can enhance and advance training and education. And finally, we're really fortunate to have with us tonight on the panel Dr. Bill Lyons. I got to know Bill more than a few years ago. We were both young people, very, like in our teens, Bill, right? That's right. When we first met, all right, when I was director of the Baker Center, a highly regarded political science professor at UT before becoming deputy to Mayor Bill Haslam in Knoxville. Now a professor emeritus at UT and associate director for community outreach at the Baker Schools Institute of American Civics. He brings to the table a really deep understanding of the making of policy and the functioning of government at all levels. So I'm already forgetting to advance my slides. It's just horrible. There you go. So with that impressive lineup, I'm just going to say a few words before we get started. I promise not to pontificate because these guys know more than I will ever know about AI. But so I'm going to stay mainly quiet, but just a few intro thoughts. As we think tonight about our hopes and fears for AI and how other technologies have impacted our lives and our society, so we're going to look back at radio and railroads, let's remember the words of a certain Conrad Gessner. Conrad said that the modern world was suffering from an overabundance of data and that it was harmful and confusing. Now, I will say Conrad wasn't talking about AI or even the internet, not even radio. He was writing in the 1500s and complaining about the ill effects of the printing press. So I will say our tendency to both embrace new technologies and to be wary of them is by no means a 21st century phenomenon. If you look at the time frame we're examining tonight, kind of early 19th century through today, starting with the advent of the railroads, radio, and up to AI, you'll see a chorus of voices saying that each of these technologies will grow the economy, prevent ignorance, improve communications, and so forth, balanced by other voices saying the new technologies will steal jobs, increase ignorance and idleness, put up barriers between peoples and groups, and just maybe, in the case of AI, establish a worldwide net that dominates the human race with androids that look like Arnold Schwarzenegger. So now our humble task tonight, is to take a look at AI from both the perspective of how it's developing and is likely to develop, and then of how it might compare to the positive and negative disruptions caused in the past with the advent and growth of the railroads and radio. Now, we'll preface this by saying I'm not an expert on railroads and radio. So I do know some. I've done some research for this, using some AI, honestly, yes. But the basics of the impacts on society will be represented here tonight in several broad categories, and then I'm going to ask these really smart panelists to help me think about how that compares to what they think is happening now or will happen with AI. But first, what is artificial intelligence? I, before this, went to Dr. Parker and said, you have 5 minutes to tell everyone what AI is. She tonight has asked for 6 minutes. You can have this, Lynn. All right, so there's all yours, Lynn Parker.
Thank you. Good evening, everyone. So what is AI? Hopefully, most of you recognize that anytime you use your smartphones, you are using a lot of AI. Just to open up the phone with your face, that's AI. Or you may use a voice assistant. Or you may have an Apple Watch that detects when you have a hard fall and calls 911, or maybe it detects when it thinks you're having AFib. All of those kinds of applications are AI. But hopefully, you're also very much aware that AI is touching nearly every sector of our society, from education to healthcare to manufacturing to agriculture and so forth. And so what that means then is that there are a lot of different kinds of uses of AI, and at face value, they seem all very, very different. But conveniently, there is one fundamental idea that most of these AI systems are using in order to actually work and do all of these things. So what is that? The basic, relatively simple idea behind AI systems, to simplify, is that we want to go from trying to write out explicitly all the rules of what we want our system to do, and instead enable it to learn from lots of data. So the old style of programming, traditional programming, is where you write a lot of rules. You say, if this happens, then do that. If this other thing happens, then do this other thing, and so forth. But with AI, now what we're doing is we're setting up a system for the AI itself to be able to learn using lots of data. Now, if you can tell from that little cartoon picture that I have there, most of the AI systems that we see today are built around a kind of an underlying representation called a neural network. That's very, very loosely modeled after how the human brain works. And the gist of it is this: if you can look at that sketch and you read it from left to right, so on the left-hand side, you would input your data, lots and lots and lots of data, iteratively, one at a time. And then that neural net on the inside, it has a bunch of, all those circles up there are what we call computational nodes. And so the data feeds into a layer of those nodes. So it's a column in my picture. A column is called a layer. And so it feeds in, and then there's some mathematics that happens with each of those nodes, and there's weights that are aligned with each of those arrows that are connecting the nodes, but it's relatively simple mathematics. And it feeds from one layer to the next, to the next, to the next. And in a real system, these are massive, like millions or billions of these nodes and a lot of these layers. But this cartoon gives you the basic idea, and then what happens is that at the end, you give it an input and you're expecting an answer, and then the output is either correct or incorrect, and then that information is fed back into the system, and you have a training process to help that AI learn a model of what you're trying to represent, and then that can be used in a future question when you say, present a question to the AI. So let me make this concrete with a specific example. Let's say we want to build the most important AI system of all time, which is this a cat? Okay, so we feed the system, in the old style, traditional programming, we would have a bunch of rules. So look for whiskers, check for pointy ears, look for fur, count the number of legs. Sadly, though, that does not work very well. Okay, so now in the new approach, we gather lots and lots and lots and lots of images, pictures, photographs of things that are cats, which we say, here's a cat, and things that are not cats, which we will say, this is not a cat. Or we could say maybe it's an elephant, or it's a dog, or it's a monkey. Now we feed that into the system. At the very beginning, our neural network knows nothing. And so it feeds through, it just does guesses, and then it comes out and it just says some random thing like, it's a monkey. And you say, nope, not correct. And so there's a feedback process. And now the system, the algorithm that's under the hood will tweak all of the little parameters and so forth within the AI neural net so that the next time it sees that image, it's more likely to be correct. And now you repeat this over and over and over with lots and lots and lots and lots of data and lots of training time. So this is why you hear today of AI systems taking big data centers and lots of energy, is because the amount of training time to train on big, important problems that are somehow more important than, is it a cat? They then take a lot of time. But eventually then you have a model that knows, yes, things are cats, or no, they're not. And then you can use that for future pictures or photographs that you say, is this a cat or not? And it says yes or no with a very high confidence. Now, that's a very simplistic view, but there are lots of different kinds of neural nets and lots of different ways you can structure these things. You're familiar with large language models like ChatGPT. Same basic idea. Yes, there are a lot of complications to it, but the same general idea, except it's trained on text instead of pictures of cats. Those kinds of systems work in a sort of a similar way, again, with some complications. So let me conclude by just mentioning a few things that you should also know about these AI systems. As the AI is training, it is not storing, in this case, all those pictures like a database. It's not memorizing facts. What it's doing instead is learning statistical relationships of what's most likely. So let's say you have a large language model and you say peanut butter and fill in the blank. Well, most of you are thinking what? Okay, the AI system will learn that as well, but it's not because it's memorized that per se, but it's learned that typically, statistically speaking, when you say peanut butter and, you're quite likely to see jelly as next. So it's learning those statistical patterns, it's recognizing patterns, it's not memorizing the input. And then finally, just a couple of other quick things. AI does not really understand the world in the way you and I understand it. It doesn't have common sense, it doesn't have empathy or emotion. It's really a lot of math under the hood, but it's not really sentient. And then finally, today's AI is mostly specialized. It's narrow. You can say, build a system to recognize your face, build a system to recognize some language, but AI systems today don't do all the things that human beings can do. So they're very narrow, very specialized. And when you hear of new commercial products that are better and better, usually it's because today anyway, it's because it has more data, or those models, those neural networks that are being built are bigger, or you have faster computers or more computing, or you're able to give it better feedback. So that, in a nutshell, is AI. Hopefully, it sort of removes some of the mystery of it.
You did it. 5 minutes, yes. Great job. That is terrific. So I was remembering, I don't know if you have Alexa at home, the Alexa system, anyone has that? And the other day, my wife has a new voice, and my wife said to me, without saying Alexa, she goes, I don't really like the new voice. It sounds kind of snooty. And Alexa said, well, I guess I'll have to adjust my attitude. It kind of freaked us out a little bit, yeah. So thank you, Lynn. A great introduction tonight to get us going. Our fundamental question we're going to think about tonight is, how do the challenges and opportunities of artificial intelligence compare to those of the railroads and radio? And what lessons, if any, can we use from the past to assist us today? So we're kind of ready to dip our toes into that. We're going to start with some economic impacts. I was remembering back to my presidential library days and Bill Clinton's advisor, James Carville. If you remember James Carville, he once famously summed up what was important to the American people by saying, it's the economy, stupid. So we're going to start with some economic impacts of all three technologies from a number of perspectives. First, growth. I know these are very difficult numbers to see on the slide, but let's start with the growth of the railroad industry. You know, there were 0 miles of tracks of railroads around 1827 when it started here in America. And if you look at the amazing growth of that, within 1827 till about 1840, you had about 2,500 miles built. So impressive, but not crazy impressive. And after that, by 1865, you have 35,000 miles. By 1916, so less than 100 years later, had 250,000 miles of railroad tracks in America. A truly phenomenal growth rate. And over 150,000 employees were in the industry by 1870. By 1920, 2.1 million people worked for the railroads in some way. So there you see, I know you can't see the numbers, but you get the gist of it. It went up really fast in terms of its growth, right? From the beginning to the end of, that's to the end of the 19th century. Same thing here. It's hard to see, but you see the red lines are the actual growth of the tracks across the country, beginning fairly modestly and then expanding as our nation expanded and really changing our country, which we'll talk more about. Radio, kind of same story. It grew from 5 stations to approximately 600 stations in 4 years. From 1% of households in 1921 to 75% of American households in 1937, and nearing almost 100% at one point. Radio sales in 1922 were 20 million. Sales just 4 years later, in 1926, were 358 million. In today's dollars, that equates to something like a $5.5 billion increase in 4 years. And I couldn't really find good numbers on job growth in the radio industry other than saying it was considerable. So I'm sure that also was quite a bit. So the question is this to our esteemed panel. Are we seeing or do you anticipate similar rates of AI growth? And do you see similar impacts in the economy in terms of job creation and so forth? And with that, perhaps Dr. Streifel, we'll start with you.
Yeah, I think it's a fascinating question. And I think the first piece of that, just giving a little bit of historical context as well, is when did AI first enter? When did we first start doing AI, and therefore, what's the starting point of our graph? And I think as you see with many technologies like this, AI has actually been around a lot longer than we think it has. So Len mentioned this concept of a neural network. The first time that I actually did research using a neural network was actually in 1993. So that was almost 30 years ago. So there's been a slow burn on this for a long time. I think it's a little bit different than we've seen with some of these other technologies. Is there was a slow burn, and then roughly in the mid-2010s, there were revolutions in what are called deep convolutional neural networks and some of the other things more recently called a transformer model, which is building on that, as Lynn indicated, really makes the large language models work. And that's where we've seen this disruptive advantage where from the outside perspective, we've gone from 0 to 100. So just throwing out a number right now, most businesses in America are already using AI. Penetration there is about 90% in roughly about 3 years. If you look at the economic impact of AI, if you look at just the operating income of NVIDIA, one company, that grew by 120% going from 2024 to 2025. So there's already huge economic impact. The technology curve is a little bit different than some of the ones we're talking about, but we're easily surpassing what railroads and radios did by some metrics.
Any comments on that?
Yeah, so I'll add on, and I think you hit the key points. The technology's been around for a while. I actually went a little farther back to the Turing test and the logic theorist in the 50s. The sort of when the AI term was coined, but I think you hit on the key points. There was this really slow burn, and part of it was waiting for the infrastructure to catch up, the computing power to catch up, and we've hit that curve to where now we're not resource limited in the electrons and in the compute power, at least to some level. I think there's going to be another evolution as we maybe get to quantum and some of those things. But we had to let the technology catch up to the algorithms to be able to really take advantage of it. And now it's almost ubiquitous. It's in our everyday lives and our life. And What I get excited about is, my mother-in-law who's in her 70s uses it every day. She doesn't even realize she's using it, but it helps her. That's really kind of the key point.
So, related to this, when I was looking at the railroads and radio and how they developed economically, if you look at the railroads in the early years, they went through periods of boom and bust. So up until the Civil War, they were there, and then a lot of companies went under as they tried to grow those rails. Radio was more consistent in terms of its growth. Really, with railroads, you don't see that consistent growth until after the Civil War, and then you see massive growth. Assuming what you're saying now in terms of how pervasive AI already is, does that mean we're not going to see a boom and bust in terms of that type of involvement in our engagement in our economy, or will we see that ups and down in terms of AI's use by our society?
I mean, one thing that I will note, I think that there will be, there's growth. There may be a bit of a bust as it relates to the build out of data centers and energy and that kind of thing. Not the overall use of AI, but that infrastructure that we see so much now with the energy and the data center build out. And then it will, I think, once we figure that out, there'll be more of a steady growth. I think, one of the possibilities down the road is that the research for AI gets better and better, and we figure out ways to do some similar kinds of capabilities using AI, but it doesn't require as much data and as much training, and therefore you don't need these big data centers and the energy. Right now, there's a lot of activity around how we build out that infrastructure for those large-scale training systems. But not all use of AI, of course, requires that. And you only need it for the training. You don't need it necessarily for the applications. So I think there's kind of a mixed set of things that might be happening there down the road.
So still in the economy, the growth of railroads and radio, it kind of tentacles into our country, into our society, of how they affected so many different things. I'm forgetting slides already. Again, I'm horrible. It's a real weakness of mine, ladies and gentlemen. I put together nice slides and now it's not working, guys. Oh, there you go. Yes, we'll go past that. Here you go. So, yes. There you go. The economic impact in terms of revenue generation and job creation, also seen in associated industries and technologies. So if you look at railroads, there we go. Hang on, I'm going way back now. Hang on. Okay, it's just all messed up now. I'm going to the very end. There's the beginning. There we go. There's the whole thing. That's the whole thing. We're going to go back to nature. There you go. All right, guys. The technology people need to help. This is okay. The blank screen. You know what's happened, don't you? AI has taken over.
Yes.
It doesn't like what we're saying, ladies and gentlemen. No.
That's right.
So if you look at railroads, the immense effect it had on the growth of steel, oil, coal, tools to both create and repair trains and train cars. It impacted other sectors of the economy. Amazing growth in agriculture and industry, obviously. In travel, this communications for business, it changed how railroads changed how we did business, created new models of management, of finance. So again, if you look at almost every sector of our economy, of how business operated, railroads had a role in changing that throughout the 19th century. Radio, kind of the same way, equipment that was developed, vacuum tubes, transistors, services like advertising, the entertainment industry itself, all help change our society culturally, economically, even politically. A very profound kind of deep impact that those two industries had on our society and on our economy. If you look at radio, even, you can say that you can draw at least a dotted line from the development of radio to television, to early radio systems laid the groundwork for modern cellular telephone networks, wireless data. So the beginnings of many different changes in our world. So this is a very big question, I know. What do you see then as possible technological or business outgrowths of the growth of AI, and what opportunities or challenges might they pose to us? And let's see, I'm going to throw a coin up in there and go, Dr. Lyons, what do you think?
I think there's a lot that's going to happen because when I look at this, I see a series of exponential curves that are exponentially increasing in their rapidity but which they grow. So, I mean, before I get into the economic and technological outgrowths, I want to add one more variable to the equation, and that is the ability of humans to function within this kind of growth. I mean, there's this book, Future Shock, came out decades ago, still a lot of wisdom in there that, how can we accept this exponential growth with so little time to process it? I think, like Ashley's mother-in-law, I'm in my 70s, and I can remember I've been an early adapter of virtually everything that's come along. I had the second Apple II in Knoxville. Remember going to the first time I ever saw a spreadsheet, thinking, this will revolutionize everything. I don't have to add up all these numbers. It adds them up. I can change one into some. Just that realization, and it's been a continuing realization of the technology. And what's lagging, and what I'm going to introduce into this, is our challenges we have as people to interact and function effectively, to make public decisions, to interact, to govern ourselves, to communicate with ourselves. The amount of knowledge going from that transistor, I remember when the radio went from tubes to one that you could carry around, which was a big revolution. Some of you may recall. All of those things had some kind of social impact, but the social and political impact of AI is going to dwarf all of these. So during the time of all of this phenomenal technological growth, we've had almost I won't say a decline, but it's looking like we've had a decline in our ability to interact and function with each other as human beings. So, you might say, well, the social sciences need to catch up to the hard sciences and to the engineers, et cetera. And that's true, but we don't really know how, because it doesn't work the same way. So, I didn't think I answered your question at all, but maybe through open...
I know how you operate, Bill. I know.
Trying to have a devious plot here. But I do think that just trying to understand what's going on with the speed that it's going on and the degree to which it exceeds most individuals' ability. I don't understand how radio waves work. These waves are going through the air. I mean, I can talk about them, but they carry information. And then the same thing with TV, and then signals for phones. I mean, all that is still sort of a mystery. So I don't know where we're going with AI. Of course, I use it, play with it. Gemini, ChatGPT, all these different elements of it. Which ones do what? Where does it function well? Where does it not function so well? And it's absolutely frightening to me how much better it's gotten in the last couple of months, let alone couple of years. So that's what I'm thinking: exponential change, growth, change, impact. I think that's a very sobering thought.
So your question of how we can address this from a personal point of view, a human point of view, part of that's what we're doing here tonight, right? We're trying to learn about this. I'm proud to say AMSI also is part of that, of how we help teach about that. We can teach you all about the electromagnetic spectrum, Bill. If you want to come over, we will do that. We got some really smart people there who know a lot more about that than I do. I remember when I worked in DC, when I first got an email system. I'm not like Bill. I'm not a quick early adopter. And we got Higgins email. I don't know if anyone remembers that. I thought, what am I going to do with this? If I want to talk to someone, I'll call them or I'll write them a letter, And now with that email, forget it, right? The day is over. So does anyone else have anything to add on that question? We can move on to the next.
Yeah, I think, I'll start off by saying, unfortunately, I'm old enough to use this quote, Marshall McLuhan, the medium is the message. And I think that's part of the social aspect that we're going through. But I think there's also another important unraveling that we have to do here. There's a difference between transportation and a train. A train is a method of transportation. The train is the application that runs on the rails. And there's a similar conversation about AI and computing hardware. And AI is an application that runs on computing hardware. And I think the analogy to the spreadsheet is a really important one. We've had lots of revolutions in the software that we use, email, spreadsheets. These are embedded in our culture now in a way that if you go back 40 or 50 years, people just couldn't imagine. And that made obsolete certain ways of doing things. I think if you look at that in that perspective, and getting back to one of the links that Lynn was making, the hardware that we run AI on right now is by many metrics really, really, really bad. And I think that's something to remember. And that's where part of the resource conversation comes on. AI is not resource intensive. The hardware that AI runs on is resource intensive. And that's an important distinction to make. And let me draw the following parallel. The computers that we have at Oak Ridge are still some of the best in the world for running AI, doing model training, and doing what Lynn refers to as the answer, which is called inference. That machine runs at about roughly 20 megawatts. Human brain, 20 watts. 1,000,000 times better than the artificial hardware that we've created to do something similar. So there's a lot of room there to do differently in the technology, and I think that's something we have to consider. One final comment on that, which gets to the same point. How many people in the room think NVIDIA is a hardware company? Those of you who know NVIDIA is. NVIDIA is a software company. And they think of themselves very much that. Their job is to make AI work so you buy their hardware. They make money on the hardware, but they're actually selling software. It's the razor blade model. And I think there's some things like that you have to take into as we start to understand how the social ramifications are playing out that are important in understanding what the model actually is.
Kind of comparison, I guess, to you look at the change in radio models over the air, the change in train cars and train engines, that type of thing as well. To some extent, that evolution of that hardware for those technologies as well over time. I want to turn next in terms of the economic impacts on other industries. We hear a lot about how AI is going to change a whole range of jobs and industries. Looking back at railroads and radio, they both presented great challenges. Railroads immediately challenged canals, starting with the Erie Canal in 1823. By the end of the great boom of canal building, there's about 4,000 miles of canals in America alone. The railroads really put a stop to that growth. At the same time, it's true for the turnpikes that were developing. Of course, we now have a lot of roads, but that was a later development. Steamboats saw amazing growth early on, and really when railroads first started, they connected with them. So they would go up to the railroad depots, and they were part of that system. Ultimately, railroads kind of ran them out of business. I used to be director of the Abraham Lincoln Library up in Illinois, and one of the great cases of Abraham Lincoln was when the steamboat industry brought a suit against a railroad company about the first railroad bridge over the Mississippi. And when they built it, not long after they built it, a steamboat hit it and sank. And they said, "You can't do this. It's dangerous. You got to take that bridge down." It was a big threat to the railroads of their expansion west. But Abe won that suit. So sometimes he was against the railroads, but oftentimes he was on their side. So called the Effie Afton case. Radio also presented. There you see the Erie Canal on the right and the steamboat from there. Radio also presented challenges, especially to the print industry. I didn't really realize this when radio came out. There was a big fight with newspapers about who's going to carry the news and trying to limit the news on radio. The newspapers tried to use legal tools and everything to limit the amount of news that could be on the radio, ended up losing that monopoly, losing a lot of advertising revenue, but they survived until fairly recently. They've seen obviously a lot of challenges. The phonograph industry didn't really think about this either, was hard hit at first, but then they learned how to adapt and utilize the radio to help sell their product. Live performances were heard as well, but again, you see a lot of adaptation. So I think if you look again at railroad and the industries impacted by that, maybe too simplistic of an analysis, frankly, but a lot of those industries didn't adapt, couldn't adapt, and kind of went the way of the dinosaur. With radio, a lot of those industries that were impacted found ways, over time at least, to adapt and kind of have a symbiotic relationship with them. So the question to this panel again tonight: will disrupted industries' jobs today along the lines, will they move like radio and adapt, or will they be reduced or subsumed by AI over time, like some of those affected by the railroads? So Lynn, maybe I'll turn to you first on that.
Sure. So as I noted earlier, as we know, AI is touching nearly every sector of society, including all the businesses in those sectors. And Alan, I think you're touching on exactly the point, which is that in order to use AI well in many of these application domains across all of these sectors, you actually have to change the way you're doing your business. You have to redesign your workflow. You have to redesign how your business operates so that you can take advantage of AI. And I think what's going to be happening is that what is happening right now is that there is a lot of investment that's going on in a lot of industry to rethink that workflow, to sort of put in that underlying infrastructure within their own facilities or businesses in order to be ready to use AI. Maybe you have to make your data AI ready, for instance. You have to have a culture of collecting data that will be useful for your AI systems. And as you do that's a cost, that's an investment in thinking through how you're going to do your business in a different way. And then you start to see, hopefully, the productivity increases through AI once you've redesigned how you do your system. The analogy here is not quite so much radio or railroad as it is electricity. When you first were able to electrify parts of an industrial operation, you had to rework how you were doing things in order to leverage that new capability. So the question then is, today, it might be easy for an industry, a company to say, well, I don't really see that there are any advantages. People are investing a lot in AI and the productivity increases are not there. And a lot of the studies show that the productivity increases are lagging behind the investments. And that's because you have to do that underlying infrastructure workflow redesign in order to now be able to take advantage of AI. So the companies, I think, that will be successful down the road will exactly be those that adapt to these new capabilities rather than somehow trying to tack on AI to their existing approaches. And I think that's what people are beginning to recognize and realize. And the ones that are ahead of the curve are the ones that have already started doing that workflow.
And I assume that workflow redesign will include not only an analysis of how that should be redesigned, but also looking at the social impact of that, how the people then involved in it will react to and respond to that new workflow.
Exactly. I mean, so much of it is how do the people in the facility, in the industry, in the business, how do they work with AI, often as a tool, in order to do their job, perhaps in a different way, or do particular tasks within their job in a different way. And I think it's really a management decision here to figure out how to do that most effectively.
I might add that a lot of what we're talking about is making tasks easier and more efficient, which is what most businesses want to do. There's one enterprise where that's not what we necessarily want to do, and that's education. The idea of writing a paper. Well, if you're going to produce a paper, I'll ask ChatGPT to write the paper. Why do I need to do it myself? And students actually don't understand that sometimes. It all goes back to what the value of learning is and how one learns and whether you really want to learn a process and what is going on, or do you just want to get to an outcome as quickly as possible. And I've always fought against the latter all the way back. I taught statistics for years, and people would want to, the book would say, let's use the computational formula. I said, well, maybe eventually this is pre-computer. Maybe we'll use the computational formula, but it doesn't reflect what's going on. Let's go through and do it by hand one time, the long way, so you can see, well, there's a predicted and there's an actual, and look at that. they understand it a lot more. I would say, you know, being still in the university setting, that it's very challenging to figure out how to convince students that just getting the outcome quickly is not necessarily what we want to do. We want to get into the logic, the understanding, the thinking, the principles, and that has made it. God, everybody's talking about this all the time. You pick up the Chronicle of Higher Education. There's an AI horror story there every week, but this is again some of this impact we're talking about. So how are we going? What is learning going to be like in the future? And the last thing I'll say is I tell every student and all my colleagues, don't fight the tech. It's coming. We got to figure out how to effectively utilize it and do so in a way that makes lives better, rather than kind of putting up your hand and going, you know, all right, we can't do this. We got to figure out how to use it.
Luddite approach will not work on this, Ashley.
Yeah, so I want to kind of tie both of these comments together. Whether it's business or individuals, AI is an opportunity. So it depends on how we look at it. If we look at it as an opportunity to find efficiency, to adapt, to do things differently, then we can embrace AI and actually win at a lot of things. You know, it used to be in business, you would hire programmers or computer scientists to write code for you. You don't have to do that anymore. You can ask one of the AI models to write code for you. If you have a Microsoft product, you have Copilot built in and you use text, it can write the code, copy, paste, and you have the answer. But that doesn't remove our responsibility to think. And so shifting the way that we educate to focus more on critical thinking and embracing the technology, using the tools, teaching how to use the tools in the classroom, and shifting it from more of the answer ABCD on a test to having more conversations as a teacher and student, more of the Socratic method of learning. Then all of a sudden you dive deeper into what is the critical thinking? How are you embracing the context and the logic of what you're doing? And AI just becomes a tool along the way of learning.
You guys got ahead of me here. It's good though. I love the conversation. See Mark Buckner up here today. You know, Oak Ridge schools are amazing in how they're embracing technology and kind of being at the forefront of all this, of how we teach students today utilizing AI and teach them about AI. You know, looking back at railroads and radio, I did a little research. You know, when it came out, they both impacted education in many ways. There were educational programs on radio that, from what I learned online, were deadly dull. They got better over time. But you do see this broader then dissemination of ideas and training and education on the radio. You see connections of communities, people being able to move back and forth, teachers moving back and forth, ideas, materials moving back and forth on the railroads, but also bad information, right? And propaganda and so forth. They're moving on those same radio waves and rails. So again, you had to be, the word I kept on coming back to was discernment and perspective. Critical thinking, as Ashley said, of being able to apply that both as a teacher and as a student. We might hop back to that in a moment. I do want to say again, we're at about 6:45 or so. Raise your hand if you have a question, because soon we'll have to stop taking those. So pass them to the ends of the aisles. Thank you all. I see several hands up. Wonderful. I do want to turn, before we run out of time, to the issue of legislation, regulation, kind of government oversight versus deregulation. Both railroads and the radio, when they came into being, led to a flurry of debates and ultimately regulations, but then deregulation back in the 1980s and 90s. So I've just put up some of the legislation that applied to railroads, the Interstate Commerce Act starting back in 1887. A lot of concern, especially about safety, and then also about workers and so forth, their rights. So you see that developing throughout the late 19th, early 20th century. But then by the time you get to the 80s and 90s, you start seeing the deregulation of the railway industry. Same kind of with radio. early on, a ton of patent litigation. I learned a lot getting ready for you, ladies and gentlemen. Thank you. I learned a lot about this. And then the radioactive 1927, the government control of the spectrum, leading all the way up then in the Carter and Reagan administrations to deregulation, including perhaps most famously the elimination of the Fairness Doctrine in 1987. So I see this a lot in the news nowadays about the regulation of AI. Should it be regulated? If so, how can we do that without hampering our ability to stay competitive with others in the world? And then is this cycle of regulation and deregulation an inevitable part of how we do things? So I'm going to, Stephen, let's turn to you.
Yeah, so there's, I think the safety implications of AI are, something we can't really underestimate. And I'll give you a great example. We really don't want AI developing nuclear weapons. I'll just put that out there.
That's
I think this room, if any, can agree on
point
that.
number one of the night, Steve. That's very.
Yeah,
That's
I think we
that's
can
the
all
most
agree on
important
that.
point of the night.
But the reality is, the design of a nuclear weapon is actually not that technically difficult. And without guardrails, the models that are available today could easily design a nuclear weapon. And there are lots of examples like that. And I think, in many ways, this is a very different technology than we faced before, because of the speed at which it interacts and because of what I would say is really the following point. So you brought up the invention of the printing press. Since the invention of the printing press, the access to information of any human being has just grown exponentially. And you don't see Da Vinci's anymore. You don't see Leonardo da Vinci's anymore, Ben Franklin's anymore, who had the ability to wrap their mind around literally the totality of human knowledge. AI can. Can't do it, as Len has already pointed out, in a way that it actually understands it, or it can think in what we would call truly creative ways yet. I think I'd also point out that we don't really understand human consciousness, so understanding machine consciousness is kind of up in the air. But AI is the first time that we've really had a technology that's starting to bend that curve around, where at anybody's fingertips now is literally the entirety of human information. And that is transformational. And there are huge dangers associated with that, frankly, we know there are dangers that we don't know how to regulate. I think there's going to be an active period over the next few years where people are going back and forth on what the right approach is. And we've got to hit the right balance because, I don't mean to make it overly dramatic, but getting back to the nuclear weapons example or design of a new disease, the future of the world is really at stake on this.
Your knowledge of government, what do you think?
Well, there's an impulse to regulate things like this, and hence is what happened with the railroads and with radio, and you can understand why that was the case. There's fear sometimes of overly powerful monopolies and all the things that you wanted to keep. Competition sometimes is the issue. Safety, obviously, sometimes the issue. Regulating what we're talking about and what Lynn so wonderfully described, I think is pretty much almost an impossible thing to conceptualize. Already states started off, well, we wanted to have something in Tennessee or something in Mississippi, and that is a clear loser. I mean, that never going to work. So this is it's an international phenomenon, but in our grasp, it's national unless we work with treaties. And where we're going to end up is the inevitable deregulation if we go that direction. However, there are areas around the fringes where the regulation and where government is going to come in and in some ways end up regulating its reach, and that's around the generation of power and how that works. The Musk's AI operation in Memphis has gotten tremendous pushback from neighbors, and then there's pushback on who's paying. Is this whole cost of electricity shared, or is it going to be owned particularly by the company that's at work here? So that leads. There are state and local governments and all kinds of regulations that can make it more difficult to get the computing power because of the inefficient computers that we have relative to the human mind. So I see some of that happening, but I think the actual government regulation and manner that we think of regulation, and it is going to be very difficult and I think kind of a fool's errand to try to pursue. I can't even conceive what the regulatory framework would look like myself. And so I guess I will leave it at that, which means for a while it's going to be the wild, wild west, which kind of is now, and maybe it'll end up being the Wild West for quite a while unless other areas of human existence push back on it in terms of its impact, on power grids and neighborhoods and everything else that people have to live with.
So when you think about AI regulation, obviously there are a lot of different use cases and a lot of different approaches. You can if you wanted, you could regulate AI as a technology, and that's what the European Union has attempted to do. They have put in place what's called the EU AI Act, which regulates AI writ large. And it has not been particularly well received, I will say, because it's trying to regulate all AI as a technology. And so that's an approach that the United States is not following behind. But what we do end up with, in the lack of congressional regulation that works for all states, what we now are in is a situation where all 50 states are doing their own version of regulation. And there are now thousands of bills across the country of regulating AI. You can imagine this presents a problem with companies that want to have an AI system that will operate in all 50 states, and now they have to abide by 50 different sets of regulations. That doesn't work either. And there's been a big battle, if you followed this, in Congress and even within certain political parties, as to whether or not this ought to be stopped, preempted at the federal level or not. The president, you may know, recently, end of last year, signed an executive order that said we want to have only one rule and that the White House will work closely with Congress to come up with what that will look like. So that's the big question as to what that will look like. I will say that generally speaking, I think the current administration's approach is that you want to have a sector-specific regulatory approach. And we already have that. We have regulatory agencies like FDA that regulate medical devices, or Department of Transportation that regulates, say, automated vehicles. And we have a lot of these different regulatory bodies that can look at particular use cases and decide what we need to do in that particular case. Now, there's also the existential risk kind of situations that Stephen is talking about.
And I make my career being dramatic, so I just want people to understand that.
Yes. And those also need attention, and I don't think we have an agency per se, but there is within government a center called the Center for AI Safe Innovation and they changed the name, Innovation and Standards and Innovation, that has been set up to be able to work with the federal agencies to look for exactly these kinds of challenges that Stephen is talking about. So I say all that to say it's a complex landscape. I think there will be regulation, but I'm personally hopeful that it will be sector specific. So now you can look at particular tasks rather than AI as a whole.
We add one thing. There is another way to regulate. That's regulation by lawsuit. And already you got this big one right now on social media. Can't really regulate social media, but you can sure sue people for damages on it. And I was meaning this to be a little humorous, but I think that's what's going to end up as with so many things impacting the growth curve and the nature of what we have.
I'm going to give a challenge to our panel. We have about 12 minutes before we start taking your questions. I got 2 topics. So time yourself accordingly. We have to talk, it's already been introduced a couple of times tonight, the energy impacts of AI. Railroad had some very, very significant impacts in terms of energy as well. Timber, coal, oil, the growth of cities that the railroads helped create, tons of energy requirements coming out of that. Just looking at timber alone, in the early 20th century, railroads accounted for some 25% of total timber use in the U.S. The same for coal. With radio, of course, you had electricity, batteries, energy demand for transmission and use as well. So great energy demands that these new technologies, these new industries brought along with them. So the question is, and we've started answering this tonight, how do the energy requirements of AI compare to those energy requirements, or is it something just, again, exponentially larger that we're now having to deal with AI?
Can the Department of Energy guys start?
Yes, please. I was already starting to turn toward you, Steve.
Yeah. So if you look at data centers right now, they're using about 4% of U.S. electricity. And over the next 5 years or so, that'll probably hit about 10% of electricity. And that's a pretty significant change. But I think an important thing to put into context here is, for the first time in a couple of decades, the U.S. is seeing a general growth in electricity and energy demand overall. So the problem is not really AI. The problem is AI hitting at a time when we already have an energy supply that's stretched. And we got to solve that problem. And I would say that Oak Ridge and the National Nuclear Corridor that we represent is on the cutting edge of solving that problem.
I will just add, I think one of the unique things about the energy requirements for like AI data centers and so forth is that it needs to be co-located with where the data center is for the most part. It doesn't help if you've got a lot of energy up in one part of the country and where you actually need the energy is in a different part of the country. So I think this has created a lot of the challenges of having the infrastructure, like the transmission that you need to carry this energy from one place to another. So I think it's a little bit different in that it's very concentrated in some particular areas. Now, I've also seen some studies, speaking of the energy needs, and Stephen, I'd love to get your thoughts on this, that the hamburger industry in the U.S. uses way more energy than AI.
Yeah, and it's exactly the point that, I think looking at the local area, and it's a great way to make the point, we've got to be able to accommodate AI without driving up energy costs. And we do that by being proactive and thinking through the problems. We've talked a little bit about xAI in Memphis and the impact that they've had. That's an example of where you don't think about the problem, you get yourself into a bind because the energy is not available, and then you do bad things. But we can do it responsibly. We can do this in a way that we benefit from the good that AI can bring society without driving up electricity costs for the taxpayers. And the reason we can do that is because there is so much money to be made, at least for companies like NVIDIA, AMD, the software companies, Microsoft, Google, the rest of that ecosystem. They realize that they have to pay for the electricity, and they're willing to do that so they can make money, and a little bit of a premium so they don't alienate their customers is fine with them. So there is an environment where we can actually make this work.
So let's turn back to education as we get, this is kind of our last topic before we turn to your questions. So it's a big topic, obviously, how we utilize AI in education, how teachers use it, how students use it, how we also teach about the potential pitfalls of it, and how we again have that level of discernment and understanding, perspective that we can utilize with AI moving forward. And I'm going to turn to you on this, Ashley, first, in terms of ORAU, how you did ORTIC. How do you distinguish between those uses that are very positive and those uses that could have potentially negative impacts?
Well, I mean, I think the first is overall AI literacy at all levels. There needs to be an understanding of the positives and the negatives that can happen. Again, as we've heard tonight, it's just an algorithm. And so the human is what's interacting with it. But if we don't understand how we're interacting with it, and we don't continue to think critically through those interactions, we can be led down some harmful routes. So I think in part, helping each individual understand what it can do, what it can't do, and some of the pitfalls is part of it. As we look at what AI is today and where it potentially can go, it has the power from an education standpoint to be a personal tutor. And I think that's one of the most exciting opportunities, is that as we load more data into the model, as the model continues to learn and continues to learn us as individuals from a learning perspective, you have this private tutor. So the teacher at the front of the class can look at the macro, and then you have the ability to fill those gaps more quickly for individuals so that they're not left behind.
If I'm looking for that private tutor in an area I don't know much about, which is a lot, how do I know I can trust that private tutor at this point?
Well, so I would say, don't forget that humans still exist. Reach out to humans to test the information you're getting. But what I like to do is I'll use one AI model, let's say Gemini, to gather information. And then I'll take the output of that, put it into another model, which is built completely differently, and then test the accuracy of that information within a different model. So I'm using AI to validate AI, if you will. But again, it's actively engaging. It's an iterative process, and it becomes more of a conversation. But just like you have a conversation with a human being, oftentimes you'll go to a second individual to validate the information you heard.
That's a skill we have to be able to teach to kids, because now it's just like the same on the internet. If you want to learn about something, you go to one site. That site might be completely wrong if you're not comparing it to other sites. And the same with radio. Let's go back to our topic here a bit. You might listen to someone who's spewing something completely incorrect on radio. And if you don't turn the channel and try to find something else and put some critical thinking to the problem, you're out of luck. Lynn, you have anything to add on?
Sure. I think one of the things that I am a big advocate for is teaching the teachers, particularly K through 12 and maybe in community colleges and so forth. We're asking teachers to be able to prepare our students for these AI jobs of the future, but we're not preparing the teachers for how to do that. And so I think we need to be very proactive and intentional and create programs and resources that can teach, particularly the K through 12 teachers, to be AI literate. But in addition to really to have some examples of how AI can be used effectively in the classroom, both in terms of helping the teacher and their teaching, as well as helping the students in their learning. And this is something that I think there's a bit of a knee-jerk reaction of just saying, well, we're just going to ban AI in the classroom because I don't know how to use it well. And I think that's just putting our heads in the sand, because AI is not going anywhere. It is here, and our children's futures depend on it, being able to use it well. So I think a particular focus on teaching teachers is something that we really need to do in order to help really all of society going forward.
I want to put another slant on this. I think what is going to be valued that AI can't provide is the ability to read the room. I think the humanities are going to be reinvigorated because an understanding, be able to know how humans operate to deal with somebody and react in a sensitive way, in an effective way, I think is going to empower the teaching of things that are right now. The teaching is kind of on the ropes. You know, if the humanities and especially are under threat at most universities, and people get frustrated with them. What value do they add? And I think they do add value, and it becomes more obvious. And just maybe we can sort of close with this crazy, everything old is new again. What the response in classrooms of my colleagues has been: bring out the blue books and the pencils and hide all the technology. And I said, I remember this vaguely, because and then people write, and it's more a little bit of the soft skills. And in that sense, I think all what we're talking about can, if we're really creative about this, can emphasize what is human and what we know and what we might call wisdom, rather than just the aggregation of zillions of facts. Now, the aggregation of zillions of facts can really be helpful. Say one quick story. 2000, I was teaching a course on the election Bush v. Gore. When the Supreme Court decision came in, I had to go to great lengths to find that, to get the actual decision and bring it to class. And then that was his paper. Where now, and that was 2000, now, not even before AI, just with regular Google search, let alone AI, any case, all the legal research is done for you, all the background, all the references, all the implications, all the stuff done at whatever court is there, and it's instantaneous. Now, to Lynn's point, take that ability and then really get into the essence of what's going on there, rather than the mechanics of just assembling the opinions or giving a multiple choice test on something. So I'm putting in a plug for the keeping alive the humanities and education and literature.
Well, as a history major who became director of science museums, I'm all with you, Bill. I think that's great. I think we talk a lot at our museums about STEM, obviously, and about workforce development and all that. But I think at the end of the day, you want well-rounded students, right? Talking about well-rounded students, that wisdom. So you all have given us roughly 1,000 questions. It's great. That's fantastic. So I think we're going to turn to some of those now, and I'm going to try to leave room at the end for a challenging question for this panel. But these are great. So I'm going to throw this out, and you all jump in here. First question is: will AI increase wealth inequality?
Yes.
Right. Wow, Steve,
Yeah.
we got another 20 minutes. Come on.
Yeah, I think we've seen this with the introduction of all new technologies. We're already seeing this with some of the AI companies, where there's an enormous concentration of wealth in a small number of individuals' hands who've been able to gather resources to make AI work. We saw the same thing with spreadsheets, going back to that. Larry Ellison made his enormous fortune on spreadsheets. The robber barons did the same thing. So this seems to be something that's encoded in human DNA. So I think it's going to happen, and we'll have to figure out how to undo it later.
I'll just add quickly, from a broader sense, is most people expect this to be what's called a K-type response. Basically, what it means is there's going to be some who benefit tremendously, grow in wealth, and others who don't. And from what I've read and sort of my own personal experience, it comes down to a business's ability or an individual's ability, I'll say, to see it as an opportunity, to embrace and adapt to the technology and use it to create wealth or stay away from it. So I think we have a decision as individuals. How are we going to interact with AI? Are we going to use it, learn how to use it in ways that helps grow wealth, or are we going to stay away from it? So I think that will make a big difference.
And I'll just add quickly, I think at the individual level, this applies as well. I don't think you have to worry about AI taking your job. I think you have to worry about people who can use AI well taking your job. And so those who can use AI well will grow more wealthy because they'll have jobs than if you don't know how to use it well and you lose your job. So.
Amazing questions, by the way. I mean, looking through these, really, I've always said Oak Ridge has a lot of smart people. So, this is an interesting one, and I think really this goes to Stephen, you too, Lynn. Why does AI need so much power and nodes? They have an example here. A honeybee has about 250,000 neurons and can do some complex navigation and information processing with a dab of sugar. So there you go. I like that.
I'm going to take a guess that was Hans Martin Christian. If you don't know Hans, he has bees and he has great honey. So I'll put a plug in for his company there. If you look at what we do with large language models, these are just very, very huge statistical models, where basically you're creating a matrix of every word's relationship to every other word. And the amount of computing power that it takes to be able to calculate the mathematics behind those statistical relations is enormous. The short answer is that's not how organic brains do it. And there is actually research that's more aligned with the way that actual physical neurons in brains of not just humans, but most thinking organisms. And we're in the early stages of being able to figure out if we can do something similar. But that gets back to the fact that it really is crummy technology that we're using that sort of mimics what we can do with biology, but is by no means the same as biology.
Yeah, this argues for the importance of continued research in artificial intelligence. I think a lot of times we think AI is everywhere. It's a solved problem. We know how to do it. And we need new ways of doing AI, as Stephen is saying. I like to use this example. You show your 2-year-old child a picture book of, say, fish. And you show them a few pages, these are fish. And now we go to the aquarium, and the child can look and usually very easily look and say fish from a live fish that's running around just from a few picture book pictures. We just don't know how to do it yet at that level, at the algorithmic level with AI. And so now we need more research to figure that out.
So we ask, is there such thing as we have artificial intelligence, and Stephen described human intelligence. Is there something that's just intelligence that they converge upon?
Intelligence is in the eye of the beholder, as my PhD advisor would say.
Is that an artificial eye, or is it?
A bit about how AI is answering our questions. From the chat, AI fabricated a false answer. How can this be corrected? And then also we've heard about AI hallucinations. So can those be corrected? Tell me, how does that work? Or is that just a process of AI learning more and becoming more advanced so those answers are given back? I know Ray Smith on my board here is great about telling AI you're wrong, and it corrects it and apologizes, right, Ray? So yeah, right. Yeah.
Yeah, we may be starting to see a flattening out of the curve at which models are improving, and it gets back to exactly the point that Lynn was making. The algorithms are doing certain things, and over the last few years, there's been just really remarkable progress in making those algorithms behave better. But we seem to be seeing a point at which more data isn't helping and more computation isn't helping, and we're sort of hitting a saturation in error rate. And also the length of a task that an AI can do. So again, the curve has been exponential. No curve stays exponential forever. We seem to be bending over and seeing more modest improvement the last year or so. And we'll see what comes next. There'll be another disruptive technology that changes the game.
Well, this is a related question, really, in terms of that learning curve. This question was talked about a manuscript they were writing regarding interactions of policemen with minorities in the 40s and 50s, and in some of that, the language included racial slurs, and AI said, "I can't help you with that." So is AI culturally sensitive? Is it learned to be sensitive in that way, or is that what would that be resulting from?
No, I think it's important to remember that again, as Lynn has pointed out, AI is just a statistical process. Unfortunately, all of the bad things that are out there and all the writings that AI is trained on will be reflected if you're not careful in how you construct your model and if you're not careful in how you interpret the algorithms. One of the things that companies work very hard on, you've heard this term guardrails. Companies test their algorithms and their models to make sure that they're not giving inappropriate responses. It turns out those are actually pretty easy to get around. I think that's one of the problems we have to realize is AI is only as good as the data it's trained on. And human beings, for the most part are good, but not all of them. And it's very easy to find stuff out there that essentially contaminates the models and leads to outputs, therefore, that we would look at as being inappropriate or unacceptable.
What a lot of the AI companies are doing, and this is one of those complications I didn't have time to explain in my 5 minutes at the beginning, in order to address these kinds of cultural issues, is that they have armies of human beings that look at the outputs of the AI model and are effectively giving feedback, or it's kind of a reinforcement learning kind of process that says that is not an appropriate answer. And this is a way that you get some of that cultural acceptability into these AI systems that you can't get just from looking at the data. And this is a huge process. It's controversial because a lot of times these people are in countries that don't have a high wage. And so you're perhaps keeping people busy at very low paying kinds of jobs that are very challenging. But in any case, that's how a lot of the AI models today or the companies are attempting to address this.
But just to add one coda to that. Remember, at the end of the day, all you're ever doing is changing weights, numbers in a matrix. That's all it is. And you're tweaking those, but that's all you're doing. You're not creating information in the way that we think of human beings creating information.
There's an interesting idea here of a specific potential use of AI in terms of the medical field. So the U.S. is short by 64,000 doctors, many in primary care. Will AI allow overwhelmed doctors to refer new patients to physicians, assistants, and nurse practitioners, I guess, utilizing AI? Is this a good or a bad idea?
So one use case, the very first use case that I'm aware of, I think that got a patent, I'm sorry, not a patent, an approval from FDA for use, is for detection of diabetic retinopathy. And the use case was that you go to your primary care physician and he or she says, well, you have a high likelihood based on your diabetes that you will get retinopathy. And so you ought to go see your eye doctor. Well, most patients don't want to just go to yet another doctor's appointment. And so they were seeing very low numbers of patients that would actually go and get their eyes checked. So they developed an AI tool that could help the primary care physician detect, based on a very simple eye exam, whether or not the patient is in fact developing diabetic retinopathy. And then the doctor would say, hey, it looks like you are in fact developing this, please go to a specialist. And so that's a way of improving the healthcare outcome. And it's also a way to be able to manage scarce resources by enabling the use of an AI-driven tool that can help with some, at least, basic diagnostics.
I have a question here directed at our laboratory director. Will AI achieve sentience?
Oh, I think we've already hit that one. I can't tell you what sentience is. So I'm going to go on a little bit about digression, but it's one of these things that creeps me out in the middle of the night. So if you ever want to really freak yourself out, look up the topic of organoids on the internet.
Okay.
And this gets back to the idea that consciousness might be an emergent phenomena. That it's not something that's designed into the brain, it's something that results from the neural organization of the brain. And one has to worry if we see an emergent property of a very complex computer program that therefore we perceive as being sentient. So one of the interesting shifts that we've seen in the discussion around AI, if you go back about 5 years, there used to be something called the Turing test. Yeah. That if you had a machine that to an observer who's interacting with the machine where they could not tell that the machine that they were interacting with was a machine, then that passed the Turing test of what was defined as intelligence. You will find we have stopped talking about that test because we're way past that.
Yeah.
So that sort of begs the questions again of what is sentience, what is intelligence, and we don't understand consciousness. So it's very hard to answer that question, but I think we're in a very interesting time where we do have to start worrying about that in a different way.
So this may be a question in your pile there, Alan, but we haven't got in. It's almost a naive conversation in many ways. What about malevolent AI? I mean, everything, good, evil, go biblical, heaven, hell, that's been kind of the history of human experience in many ways. When you talk about sentient beings who make choices on their own. And by that, I mean, there are so many ways one country or one political party or one group can say, use all we can know in terms of our machine learning and all the experience about how to disrupt this society, how to have messages that set people up against each other. And of course, we're experiencing a lot of this on social media now. So it's probably it's happening at one level, but I wonder about how it can really be refined. And that's I don't know any more than how do you deal with the question of evil in human beings. But if that's to the degree that we're talking about going down parallel tracks in intelligence and being sentient beings, that I don't have an answer for that other than that keeps me up at night.
If I can add one thing quickly to that while you find the next question. One of the things we haven't talked about tonight is something called agentic AI. So if you look at most of what we do with AI right now, we're sitting on our phone or computer terminal and we're posing something to appears, for all intents and purposes to be a chatbot or a search engine, and we're getting some sort of text response back, or we're sending an image to a computer and the computer saying, yeah, that's a parrot, or that picture was taken at Notre Dame. So the next frontier is you start combining computing power that is based on AI with entities, mechanical entities that can actually interact with the real world. And this is where it really goes south pretty quickly. This is where you start saying, we have an AI-powered aircraft that all of a sudden has decided that all human beings are evil, so we're going to wipe them all out. And this becomes the Marvel universe pretty quickly.
Yeah, I've seen the movie.
So we've seen this movie. We know how it ends. But you're absolutely right to be worried about that. And that's something that we're just, it turns out agentic AI is a lot harder than the movies would make you believe it is. Thank God. So that's going to be one of the things that we start to work through over the next few years as well, as we start to get our arms around how to make agentic AI happen. How do we actually manage that in a way that we don't wind up I said I was going to be dramatic, all dead.
So a few years ago, I was at the University of Louisville and I interviewed an android. It was based on the famous science fiction writer Philip K. Dick. And that day, the neural network was not working well with it. And they were saying, we need to input stuff here more than we normally would. I said, I don't care. I just want to get the video. I want him to talk to me. And he did. And about midway through, I asked Philip, what is love? And he answered me with an answer they did not input. Now, what happened is the neural network started working better. But that student jumped about 10 feet in the air when he answered it, because it was not expected. He said, "Oh my goodness!" So
what's the answer?
Bill,
It seems appropriate this week.
No, Bill. That's something we all have to figure out on our own, Bill.
You sound like Alexa.
So there was a question in the questions from the audience that really was my last question in many ways. You have a graph here that's hard to see too in terms of the life cycle of technological revolutions, how the great growth, and then they level off, and then something new comes along. And my question was going to be, what is that something new down the road? Is it quantum, that when we look back in 20 years or 50 years, that AI was this quaint thing, and now we're in this new era? The question from the audience is, what are the end goals of AI? What purpose will it serve in 50 years? So again, look in your crystal ball, maybe ask AI what comes after AI, or does something come after AI?
So a couple things here. So, the real goal behind AI is, frankly, innovation and discovery. How do we do that more quickly? How do we put the tools at everybody in this room's fingertip so that you can do things that would have required experts that now you can do yourself? I think that's really part of the end goal. I think one of the things I very firmly believe, and this is something that might displace what we think about as AI right now, getting back to the point I was making about biology. The 21st century is the century of biology, medicine, life sciences, in exactly the same way that the 20th century was the century of physics and the 19th century was the century of chemistry. It's not that those disciplines are unimportant going forward, but if you look at what is happening with the revolution and the way that we understand biology, there will be a point where we're going to look back and say, that's the moment where we understood what life is. Maybe. And I think that will, take what we're talking about now. If you could grow a brain and that brain had intelligence and you could do that in a way which is ethical, that's a very different proposition than we're talking about with a tool that's created that runs on a huge data center. So I think that's something we have to look out for in the not too distant future.
Put on your prognostication and think what's happening in the future? No. I could come up with something wild and crazy, but I'm going to leave it at that. So I just want to thank, again, you all for being here tonight and thank this wonderful panel. Thank you so much. Thanks, guys. Great job.
Three presentations. There's Alan mentioned the next one is in March. It's at the American Museum of Science and Energy. It's about first ladies and their influence on societal change. And then in April, we have a very interesting program on immigration. We're going to review a brief documentary about a group of prospective citizens who are going to take the naturalization exam. And there'll be quite an interesting discussion about that. And then at the end of the program this year, in May, we will have a program about the next 250 years. And what do we hope for? And we hope to engage young people with that because they have the most vested interest in it. So I hope you'll join us for the remaining programs.